Alright, so today we're going to be talking about the properties of exponents. The first property is the multiplication property. So if we have a to the n times a to the m, to simplify this we would want to add the exponents, not multiply them. Okay, so again, for multiplication we want to add the exponents. Here's an example. We have 6x squared y cubed times 2xy to the fourth. So the x and 2 out in front, those are just normal numbers. It's okay to multiply those. So to multiply those, we get 12. And then we look at the variables. We want to combine the x's together and then the y's together. So we have x squared and x. That x there doesn't have an exponent, but we know if there's no exponent, it's a 1. So we're going to add the 2 and the 1 for the x and the 3 and the 4 for the y to get 12x cubed y to the 7th. Okay, and then there's the division property, where if we have a to the n divided by a to the m, we subtract the exponent. So we have to take the top minus the bottom, so n minus m. And here's an example. Again, those constants out in front, or those coefficients for the variables, we just divide those like normal. So for those we're going to get a 2. And then for everything else we subtract top minus bottom. So on the x, we're going to take 4 minus 1. For the y, we'll have 6 minus 5. And for the z, we'll have 3 minus 2. And when we simplify this, we're going to get 2x cubed yz. So the y and the z, you can put a 1 for its exponent if you want to, but usually we don't write that there. That's why I didn't put that on this example. Okay, the next property is power to a power. So if we have a problem that looks like this, where we have a to the n, and then it's raised to another exponent m, we multiply these. So n times m for that exponent. So for example, say we have 3x to the fourth squared. So what this means is we're squaring everything inside the parentheses. So not just the 4 with the x, but we're taking 3 squared as well, because that 3 has an exponent of 1. We multiply that. So we're going to get 3 squared x to the 8th. But we're not quite done. Okay, we can simplify 3 squared a little bit further to get 9x to the 8th. Okay, so if you've noticed, so far we haven't had any negative exponents, and that's because the proper way to write an exponent is positive. But sometimes you'll be given a problem in which there is a negative exponent, and we have to make them positive. So for example, if you have a to the negative n, to rewrite this with a positive exponent, you're going to put it on the bottom of a fraction and make it positive. Okay, sometimes you'll have a negative exponent on the bottom of a fraction, so to change that, you're going to move it to the top and make it positive. Okay, so again, we always want to have positive exponents. So to make a negative exponent positive, we change its location and make it positive. If it's negative on the bottom, we move it to the top. If it's negative on top, we move it to the bottom. Okay, so let's say we have this for our example: x to the negative third power, y to the fourth, z to the negative sixth, over a squared, b to the negative 2, c to the negative 2. Okay, so again, we only want to move the negative exponents. The ones that are positive will stay exactly where they're at. Okay, so here I've highlighted the ones that were positive. Okay, those ones did not move. The ones that did move were the ones that had negative exponents. So the c to the negative 2 power, it moved to the top and became positive. Okay, and then we have the x to the negative third and z to the negative sixth from the bottom, or the top, that moved to the bottom. Okay, and it looks like I also forgot about the b squared on the bottom. That should also be on the top. Okay, and then there are 0 exponents. So anything to the 0 power is going to equal 1. Okay, so for example, say we have 2x to the 0. Okay, the 2 and the x, they have different powers. The 2 has a power of 1, the x has a power of 0. So when we rewrite this, it's just x to the 0 that becomes 1. Okay, so we have 2 times 1. The x disappears completely because x to the 0 is equal to 1. And 2 times 1 we know is just 2. So that is our answer for this problem. Alright, so with all those examples we just had to use one property and that's all we did. But sometimes you're going to have some complicated problems that include multiple properties. So the first thing you want to do is the parentheses. So take care of those first and then move the negative exponents. Okay, the problems will be a lot easier if we just don't have negatives at all. So that's why we want to move those second. And then you'd want to simplify the top of the fraction and then the bottom. And then once you do that, if you have the same variable on the top and bottom, you want to simplify that together. And after doing that, sometimes you might end up with a negative exponent, so you just want to move those again. So we're going to do an example that includes every single property. And here's that example. So again, the first thing we want to do is simplify the expression inside the parentheses. So on the bottom of this fraction here, we have 2x squared squared. So simplify that, and we get 4x to the 4th. So remember, we're taking 2, we're squaring that to get 4, and then for the exponents, we just multiply. Okay, and from here, we would want to move all of the negative exponents. So on the top, there's a z and an x that would be moved to the bottom. On the bottom, you have a z that would be moved to the top. So I've highlighted the ones that have just moved. Okay, so from here, if you just look at the top, ignore the bottom for now, we want to simplify that. And that is all multiplication. So we're going to take the 4 and the 2 on top and multiply those. But for the x, y, and z, we're going to want to add those exponents because that's what the multiplication rule says to do. So once you simplify that, you get 8x squared, y to the 4th, z to the 4th. Okay, so now that the top is as simple as it can be, we're going to move to the bottom and simplify that. So simplifying the bottom will give you 4x to the 7th, because we just combined the x's. The y to the 0 is now gone, because we know y to the 0 is just 1. So we don't even have to write that. And then z to the squared didn't have to be combined with anything. Okay, so now that the top and bottom are simplified, we want to combine the top and bottom. So if you notice, we have 8 divided by 4. That's going to become 2. And then, since this is division, the exponents on the variables will be subtracted. So upon subtracting, okay, remember, take the top minus the bottom. For the x, you're going to have 2 minus 7, which is negative 5. The y couldn't be combined with anything, so it stayed as y to the 4th. And then for the z, we take 4 minus 2, which is 2. But when we did this, we got a negative exponent. So we're not quite done. We want to move that negative exponent to the bottom, just like this. And that is our final answer. Okay, so I have a problem I would like you guys to try on your own. It's this problem, pretty much the same as the previous example. Try it on your own. I will give you the answer in class tomorrow so we can see if you got it correct. If you had any questions during this presentation, please write them down so you don't forget to ask in class tomorrow. I will answer any questions you have and we'll do some more practice with this.